Our next speaker is Jing Yin from the Institute of High Energy Physics at the Chinese Academy of Science.
Hello, everyone. Yeah, my name is Jing Yin. I'm from the Computing Center of the Institute of High Energy Physics, Chinese Academy of Science. And my presentation is from the backend to the interactive based on it. Oh, this one. Yeah. This
Oh, no.
No.
Turn this way. This way.
Yeah, make sure it has.
There you go.
Oh, okay. So I would like to talk about the software we are developing named as the Interactive Analysis Workbench. So here is the outline. First is the motivation. And the traditional half-batch system workflow is like this, that the user first need to SSH login the mapping node and to edit their own programs for debugging. And after this, the user has to lay that job script and then submit the job. After that, the user has to be wait until the job is finished and get the result back. So that's the traditional batch system, and yes, so it has some characters like it's has a closed environment and offline processing, and has the backend resource utilization. That causes some limitations. First, the user need to SSH the login node first, and the user direct file access only limited and login nodes. Also, now currently a lot of popular interactive tools such as VS Code and Jupyter, etc., string only at the login node resources. So also there is no real-time job monitoring or control after job submission, and the result will be only available after the job finished. Nowadays, involving some high analysis requirements like this. Our user demands for the new and developed software. Those feature-rich developed software like VS Code, Jupyter, or Python is more and more popular over the basic terminal. And also, our user demands like to do the debugging and execution. They would like to online plotting or get some result sharing. And also some newcomers would like to make the quite complicated high runtime environment to be simplified, easy to be set up. And also we do have some users who maybe have attended some more than one experiment research. So they do have several runtime environments. They would like to switch it on demand. So that means you can see that the login node changed and the code tools changed and also the debugging changed. And also they need some job tracing. And I give an example like this. So it's a very typical type analysis physics that a partial wave analysis. The action for this is that the user first do some data cleaning, and they will do code for the parameters optimization and see the result virtually. And after that, they will optimize their code to optimize the parameters and to see the result. Yeah, that's it. And also, as the user they want to the computing and storage resources accessible anytime, anywhere. They would like to run their function time or anywhere. They would like to access the files anytime or anywhere. And currently, that in hard skills, they would like to talk a lot about analysis possibility. So here is quite a loosely definition for this. It's the infrastructure and the services that provide integrated data software and the computational resources to execute on more elements of analysis workflow. As my things that the batch system is a kind of this infrastructure of the analysis facility. So our aim is try to transit from this closed backend batch system to the open front end. So that's the motivation for us to develop this interactive analysis workbench shown as the ink. We do have a very visionary goal. So we would like to make the scientific research with just a network connection. So it could shift the backend and offline compute and store resources to the frontend and interactive way, and enable the flexible integration of the resources and application, and provide customized interactive tools for the lab experiments. Also, we hope it can offer a class and play deployment solution. Of course, now we have currently our current aim is like this. So currently we provide our users scientific research with just our web page. And we have provided a web page the interactive analysis tools with our HTCondor cluster to integrate with VS Code, Jupyter, web browser, Windows, etc. And we made this run dedicated HTCondor job slots. In this way, there is no interference in the among users. And we also provide kernel file system access. So that means that the files could be accessed just via that web page directly, and provide user upload, download, or view the file directly. And besides of this, we also give our user an initial terminal for the command line interaction. To do this, here's some key challenges. First, we need has a loose and flexible software architecture. It should be customizable, it should be configurable, and it can be ready to use deployment. And also, it should to be quite secure for the authentication and the authorization to support diverse methods for the authentication and keep the secure for the compute and storage usage. The other thing is that we need to think about to be the seamless resource application integration and to integrate the various resources. Now we have to integrate this with the HTCondor. And of course, we would like try to, maybe the next plan to integrate the Slurm Kubernetes. And now we have integrated it with the UIs and R4K. And also it provides some flexible application integration mechanism in the future. So this is the loose flexible architecture of the ink. So there are the two main parts. The first part on the front end is separated with the back end. The front end is the provide a way for the user's interaction here, and the back end here is the main part for the ink. So this is the business layers, and the business logical layers here provide the standardized file access API, application API, and computer usage API for the front end. And at this architectural layers that is need to integrate it with resources at the bottom. And this is the architecture I just said here. And about the authentication and authorization, that the ink doesn't handle the real, the authentication. It's leveraging the existing authentication mechanism as SSO or batch used password is also can be used. Besides of this, and inside the ink and establish a mutual trust mechanism among the components inside it. For the authorization, we create a dedicated ink user permission database, governed available resources, allow the applications and the resource right of the user. So this is the real deployment type I have for the authentication and authorization. For our batch system, we use the Kerberos file to be the user authentication, and also the compute and storage usage support to the Kerberos file either. So you can see from this picture that OAuth is used for the authentication between the front end and the back end. And here is the Kerberos service in our batch system. And we create a mechanism that here that covers file service provide a short-term user tickets, and we catch it here. And for the catches here in the ink and refresh it. Ink is responsible to refresh this user tokens during the job execution. And also that here is the HTCondor. It's very set up to be authenticated by the first file. And for the storage here, they set up XRD on the top of the storage here. Last one is under this XRD and this XRD. So XRD support purpose 5. So last year is under here. So all the storage and the conference computing resources for the so-called first file for the operation. About to run this application on the work nodes, we use the port forwarding. So collecting those application running on the work node, we are port forwarding. There are other kind of port forwarding we have set up. The one is the first one is we use the index for the port forwarding that to so-called can handle the VS Code, the Jupyter, and the browser or WinCD. And also we provide our user a kind of the email. That means that we let user to the SSH, the workload directly. So to do this, and we set up IP cable servers under the port forward. And this is the ongoing work. We try to customize this customization of the experiments. So that means that the resources applications database will record the specific experiment configuration. This way, each experiment has its own unified page, and also this database will handle the user's own specific configuration. In this way, we can provide each user his own unified. The current state for the ink now we publish this the test release, the test version released in February of this year. And in March, we publish the first official release. And I have actually used accept this link. Sorry, I have actually used access this web page directly without any extra work. So now we provide the user that one CPU calls with 6 GB memory for each job slots. And we just set limit 24 hours wall time for each of the ink. Since all of these things are releasing the kind of back work. So we don't think about the person can work over 24 hours. And each user can run one of each job types. And also besides of this, we also provide some special job slots for some special requirements. Some user want to do some very special debugging, so we provide a big memory and more CPU with this special job slot. And I would like to say that after this, in the publish, we do got quite positive user feedback now. And this is our next plan first, and we hope not only from web page, it can, the ink could be accessible by the user of experiment software directly. And the next thing is, I just mentioned, we would like some customization for the different experiments. And also we hope this will be the open source. And this is the summary. So the first is the traditional batch syncing has some limitation, and especially for the head data analysis now. And the ink focus on providing an active usage for the cluster, and provide the users some kind of front end usage on the backend resources. And we do have some further development with some going for the based on the head requirements. Here is the acknowledge we extend our sincere gratitude to the HTCondor team for your side fast support over the years. And with the special thanks to Craig for his really invaluable assistance. And before I do this presentation, prior asking me a question, he asked me whether I'm brave enough to do the demo. So we'll see. What? How can I change that web browser?
Change for you. Yes.
Yeah, no.
Oh. Share the wrong screen. Do this.
Okay, so this is the web page we provide for our user. Actually, it has a login web page, and just now I tried. It seems a little bit slow for the net speed, so I log in first. And here is the main. Main page here, and we provide the e-shells here. This is the terminal. I mean, the web page provide the user a terminal. Just log into our login nodes here. So this is LX login 002 is the login node of our batch system. So here is me, yeah, something like this. So this is the first function, and also we provide the file access directly. Yeah, this is my home directory of the batch system, so I can change the directory as I want here and any. Okay, and also let's change back. I can go anywhere here. I move to my home directory here, and yeah, from here I can see the user can, I mean, to open the pictures. I click it, yeah. So this picture is can be opened, and some PDF file is also supported. So to see it directly, quite convenient for the user. And let's change back. So you see the application are integrated. So if I want to use VS Code, I just click here. Yeah, now VS Code and job has created to the HTCondor and waiting for maybe several seconds, and the connector appeared. I connected. So here is the VS Code Windows. Come. Actually, the net speed is not quite good as what I use in my campus network. So you see here is VS Code, just like the laptop. Actually, this is the Ink source code and in my home directory. And also you can see here, this is the Copilot, AI Copilot here. I can use Copilot to help me to do some coding work here. And let's change back to the here. Some user would like to have Jupyter's here. Yeah, another Jupyter file created. Wait for several seconds.
Is this then going to run on the EP execution point, or the Jupyter or the Visual Studio Code, or is that running somewhere?
On the work nodes. Yeah, on the work nodes directly, and then we use a port forwarding to the web page. And so you can see this is the Jupyter's here. Yeah, I connected. This Jupyter is running on the work nodes. And yeah, you can use it as like an interactive way. Yeah, here is my Jupyter. And we provide the user some official kernels. You can see here, this is Juno Python. It's the IPY kernels we prepared for our Juno users. And besides of this official, kernels, looks like this. This is test one is the kernel in my home directory. So besides this, official kernels, also the user's own kernels could be included in these Jupyters. And let's change back here. Yeah, and also we provide VNCs here. Actually, this VNC has been, created before the presentation, and I can open it again. So connect it. We need a password here. I shorten it. Okay, so this is the VNC. This is the VNC working on the work node. It's still my own VNC here, and it can do some quite interesting things that like this. This Juno event display is really resources consuming. It's hard for the user to run it on the login nodes. But if user to run this, on his laptop, it's quite difficult. To access the data file on the batch system. So in this way, it's quite easy, and yeah, it's quite cool. Yeah, so you can see it is quite cool. And even like this, yeah, this is the maximum, and this is the inner view from the experiment. Let's change back, and here another thing we have integrated is root browser to read. The root file. Root file is quite important in the high energy research. So I submit a root browser here, and yeah, after several seconds, I think. Let's wait. Yeah, connect it here, and we connect it. Also, this is the root job running on the work nodes here, and it's a root browser here, and this is my home directory. Let's see, I put a root. Yeah, so, okay. So this is the root file located in my home directory. I open it. Yeah, this is the root file, open it. And yeah, for example, I click it, I guess. Yeah, okay. So this, yeah, I don't know too much about that, but all of these are recorded in this root file. User can open it directly to see, the visitor would like to see it directly. And let's change back. If I finish work, you can just delete the jobs here. Yeah, so this is deleted. Deleting, and yeah, finish. So luckily, I think my live demo is quite successfully. Yeah, so that's all for my side. Thank you.
So questions while we switch speakers?
So,
Here?
what happens if you're running out of worker nodes?
It's really, it doesn't need a lot of resources. Now, one job only use one CPU cores.
Right.
Yeah, so now I just provide our users 3 worker nodes at the backend. So we can support several hundred users to use this together.
So,
and if we found that there is some limitation for the resource, it's easy for me to move one of the work nodes to the Ink backend. That's quite easy. Yeah.
so you are keeping an eye, but I'm always worried about it's an interactive user interface. Somebody comes and all the nodes, I see there are 45 jobs running now, and I think it's what early in the morning, right?
Yes.
So what is the we can talk about it offline, but what happens when there's no more capacity? What do you tell the user, to go home and come back, or can they wait somewhere and get a notification when it is so that's why I'm interested in understanding your experience. Okay.
Theoretically, for the interactive job, the user should not wait for a long time. So in this way, I just put enough resources at the backend. But also, this is the enough resources. It doesn't use a lot of work nodes. Several work nodes is enough.
Yeah.
So that's my opinion. If some, I mean, how to say, some extreme thing happen, and we can make a kind of a automatic mechanism, try to switch the work nodes at the backend to this part.
Yeah, okay. So it's a part of the solution is that it's one job per user. You know how many users you have.
Yeah, we know that. Yeah.
Yeah.
Okay. Thank you.